All right, so today's assignment is about renewable, non-renewable resources. And first off, energy itself. We kind of talked about energy because we kind of did a couple assignments about power, and power is pretty much not the exact same thing as energy. It's not exactly the same, but all it is power is how fast are you using energy. So it's almost the same thing. It's energy divided by time is all it is. So if you know how much energy you're using and you divide that by time, you can figure out power. So energy is the ability to do work. In our sample problems yesterday, the work was just to lift a weight up off the ground, which I think you guys all know requires work. If you wanna, if somebody said, "Hey, lift these weights off the ground," you'd be like, "Hey, that's a lot of work," because it is work. So energy is ability to do work, and we all know how that works. You have to eat food because food has energy, and then it gives you energy to do work, right? To like lift things up and think and all that stuff. Energy sources are defined as non-renewable, renewable, and inexhaustible. The sun is the original source of almost all energy sources on the earth. So pretty much every energy that you find, even the food you eat, is coming from the sun, right? So if you eat some sugar, the sugar grew in a sugar plant, which got its energy from the sun. Um, if you eat some eggs, the eggs came from a chicken. And energy in the eggs came from the energy in the chicken. The chicken's energy, it got it from maybe picking insects or grain. So it ate plants like little grains and seeds and stuff that came off of plants that got its energy from the sun, or it maybe ate insects that were eating things that were made by the sun, so plants. So one way or another, it always comes from the sun. Almost every energy here. So there's the sun. Look at that big red ball. Energy sources that cannot be replaced once used. So these are non-renewable energy sources. These are sources that cannot be replaced once we use them all. So fossil fuels um, are one of them, and fossil fuels is oil, or coal. So there's some coal right there. And oops, I keep clicking the picture there. And one second here, I clicked off my stuff here. All right, there we go. And oil, of course, is another one, and natural gas. There's only so much of this stuff in the ground that we can keep pulling out. Any fuel that is not identified as a fossil fuel. So alternative energy is any fuel that is not identified as a fossil fuel. So here's the main fossil fuels: coal, oil, and natural gas. Anything that's not that is alternative. So one of them, sources that can, so non-renewable energy sources that cannot be replaced once used. Uranium. Uranium. Once we use all the uranium on Earth, there's no more left. And uranium is used for nuclear power plants, although that's not the main. I think there's new nuclear materials we're using, but still, there's only so much of this stuff in the ground. 20% of the world's electricity comes from nuclear power. So we just we if you want to know how a nuclear power plant works, it's not magic, guys. It's pretty easy. You get two pieces of like uranium, let's say. This is like the simpler way to put it, but you kind of get some radioactive stuff. And when you get that radioactive stuff near each other, they start reacting. Obviously, if you put too much, you can make a bomb, which we already know, nuclear bombs, but they don't use that much stuff. So you cannot make a bomb like out of the stuff they're using here in the nuclear power plant. There's not enough of it. But if you get it really near each other, it won't explode, but it will get super hot. And the atoms are ejected off of one and hitting the other one, and it gets super, super red hot. And they can control how hot it gets by putting a barrier between them when they need. They're saying, "Hey, it's getting too hot. We can put like a big barrier of lead in between, which stops the neutrons and stuff from whacking each other on each side of the metal." And in the end, when you get this uranium nice and hot, it literally just boils water, and that water is shot through pipes and into like little turbines that spin and make electricity. Okay. Sources that can be replaced. So renewable. These are things that can be replaced. Sources that can be used. Animals. Like I don't. How do we get energy out of an animal? I don't know. Maybe you could put a hamster on a wheel, right, and and have it running on the wheel, and then you make electricity. But technically, it is a renewable resource. Food, biomass. Biomass is plants and stuff like that. Biofuel, ethanol and methanol, those are fuels that come from plants. Hydroelectric. Hydroelectric is like a dam where you put water on one side of a dam. You build it up. You build a dam and you stop water from flowing, and it builds a ton of pressure on one side that's trying to push the dam and break it down. And then you open up a hole, and the water comes flying out really fast. And when it does, you let that water travel through a turbine, just like a nuclear power plant. You let that water fly through a turbine, which spins it and makes electricity. And here we go. So here's the reservoir on the left side, and all the water is built a lot of pressure down here, and the water comes through. It's allowed to go through this turbine. The only way out is to come through here, and then what happens is this thing spins, and when this fan thing spins, it turns this generator, which makes electricity. Alrighty. Oops, I keep clicking the pictures here. I gotta click off to the side. There we go. Geothermal is just heat within the earth. Because of all the pressure and the radioactive material that's in Earth and all the pressures that go in by crushing from gravitational pulls, there's a lot of friction down in the Earth, and we know that there's lava and all kinds of stuff down there, and it's really hot down there. And some parts are really hot near the surface, and some parts are not. So if you can find a spot where the hot stuff is near the surface, then you can drill deep enough to get near that hot stuff. And what happens is you inject water in, and it gets super hot, and it kind of flies out. The water comes out steaming hot, like a sort of like a geyser. You know those geysers in the national parks where water just flies out of the hole? Except they're making it themselves. They're just taking water, squirting it in one side, and then it gets super hot and flies out the other side. And then, of course, once again, that water comes flying through turbines, spinning those turbines, which spin motors and make electricity. Same thing here. We got to make a motor spin, right? We got to make a turbine spin, and we got to make electricity, correct? That's pretty much the same thing even in a nuclear power plant. In the end, you just need something that moves really fast, and then when that liquid or fluid travels past the turbine, it spins it, makes electricity. Wind is no different. Wind is a fluid, just to let you know. It's not a liquid. Of course not. We're not breathing a liquid right now, but we are breathing a fluid, and air is a fluid. And when air is moving along like a river flowing around the atmosphere, these little fans, these turbines, can grab some of that energy and make electricity the same way as all the other stuff does. So, same thing. Hydrogen. So there is energy in hydrogen, and it can be made. And the reason hydrogen can be made pretty easily is because hydrogen is like the most abundant element in the universe. In fact, there's two hydrogens on every water atom. So you can pretty much take water atoms and split them up with using a little bit of electricity and get hydrogen really easily. And then you can make a car run on that. 1 second here. Alright, so next is solar. Solar energy, which you guys all know about, is there's a couple ways to get solar energy. One is to make these gigantic mirrors. Do you see this mirror on the left side? And what happens is it focuses, you can see it's kind of curved, and when the sun hits this, all that sun energy bounces back into this thing, making it really, really, really hot. And then you have water injecting in, and it's very much like a nuclear power plant or the geothermal, where you're getting water super hot, and that water tries to leave, like expands into gas and steam, and then you make that turn turbines, you make electricity. The other way is using photovoltaic. Photovoltaic is when the sun hits like a special material of silicon, and it excites the electrons. The energy, the electrons in the material absorb the sun, and they get excited and fly off down the wire. And we all know already, right, that when you have electrons moving down a wire, you have electricity. So these make electricity directly using photovoltaic, meaning photo is light, and light hits these materials, gets the electrons all excited, and the electrons go flying off down the wire, making electricity directly. You don't need any steam or anything to do it on these photovoltaics. These have photovoltaics on them, these satellite dishes, and you see a lot of homes on them too. I don't. Have you guys seen this one right here? There's one like this. If you guys have been to Vegas, on the way to Vegas or way to Nevada, if you drive right before you get to the Nevada border in the middle of the desert, absolutely nowhere, you'll see this gigantic tower, and you literally see these beams of light all over the place whacking this tower. It hurts your eye to even look at it. So I would say try not to stare at it, especially if you're looking at that little spot at the top where it's getting really hot. What happens is it's literally like miles of mirrors that the sun is coming down from the sky and whacking these mirrors, and these mirrors all point to one spot in the tower, making that tower super hot. It's pretty much like this guy right here, except it's like a giant tower, and that thing can make like enough power for a city. It gets really, really, really hot. There's a lot of energy flying, all that focused energy all into one spot. Uh, I pity the bird that flies through that little spot right there. So I can't imagine what would happen if a bird flew right through that thing. I think it would just be instantly vaporized from all the solar energy in that beam. Especially like right near it. If one just kind of dove through that, I don't. I would like to know kind of what would happen. I think it would just instantly just vaporize the bird. They probably have stuff that try to keep the birds away, like maybe certain noises and stuff that keep birds away. Anyway, that gets us to today's assignment. Let's talk about today's assignment. I'm going to find it right now for you guys. There we go. Let's move it over here. And week 5, Wednesday, that's today, renewable energy. We go here. Let's go to view assignment. And let's go here. And if it says renewable energy research right here, and here's the PowerPoint I went over. So here's the PowerPoint I went over, and here's the renewable energy research, and click on this and you can print it. Or I've seen some students already using Cami and stuff. I don't have that set up, but if you want to use that, you totally can and write directly on this. You can also just write this all on a separate sheet of paper. I'm fine with that. Or if you have some other tool. But pretty much you need to choose a renewable energy source. Look at the PowerPoint. There's solar and hydrogen and all kinds of stuff. Wind. Use the internet. And where does your energy source come from? What process must occur? And then like what it says, what process must occur to produce usable energy from the source. So like I need sun to hit my house, or I need wind to blow, or whatever. So then it's got all these questions. It's pretty much like a research paper, but it kind of gives you the step-by-step guides of what you're looking for, what you should be adding to it is all. Okay, so that's pretty much it.